So another way of proving statements is called using the contrapositive. So suppose we want to prove, or suppose we start off with the statement, if P happens, then Q happens. Well, the contrapositive of if P, then Q is defined as if not Q, then not P. So in terms of notation, remember not Q is written like that and not P is written like that. And if we want to combine them using if and then we draw that arrow there saying if not Q happens, then the result is not P happens. So this statement is called the contrapositive of if P then Q. Very importantly, why is the contrapositive useful to us? If we can prove that the contrapositive is true, then the original statement, if P then Q, is also true as well. So if we want to prove that if P then Q is true, and it's a bit difficult to do that, then we can prove the contrapositive, or try to prove the contrapositive. If we can show that if not Q happens, then the result is not P, then we essentially have proved that the original statement is true. Why these two statements are pretty much equivalent, you can read a textbook about it, but take it from trust that it does work. One note though, this contrapositive is not the same as the converse statement, which is if Q then P. So it's not the same as the converse, which is Q implies P. In fact, proving converse to be true tells us nothing about the original statement of P implies Q. So contrapositive means if not Q, then not P. If we can prove the contrapositive is true, then automatically the proposition, the original statement, P implies Q is true, then the original statement of P implies Q is also true. But just because we showed the converse, Q implies P, to be true, it does not mean that our original statement is true. Proving the converse means nothing to us. We can't gather any results from that. Okay, so let's apply this to example over the page 16. So it says here, consider the statement, if n plus m is odd, then n does not equal to m. Part A says, identify the propositions and write the contrapositive statement. Okay, so recap, essentially, our original statement is P implies Q. The contrapositive statement is if not Q, then not P happens. So first of all, we need to identify what is P, what is Q, and then what is not P, what is not Q. So originally we start off with if P happens, so this is P, then Q happens. So P is n plus m is odd, and then Q is n not equal to m. So let's write that down. Part A, P statement is n plus m is odd. My Q statement is the result, which is n not equal to m. So originally the statement is if P happens, then Q happens. We want the contrapositive, which is if not Q, then not P. So we need to write down what not P and not Q means. So if P is n plus m is odd, what's the opposite of that? Well, n plus m is even, because the opposite of odd is even. And then if Q is n is not equal to m, what is the opposite of that? Well, the opposite of not equals to is equals to. So not Q is n equals to m. We want to write down the contrapositive, so write down the definition of contrapositive. So contrapositive statement says not Q implies not P. In other words, if we translate it back to our PQ statements, our contrapositive is if not Q, which is n equal to m, then not P happens. So n plus m is even. So that would be our contrapositive. Part B says prove the original statement to be true by proving the contrapositive. Okay, so remember when we start off with proofs, we always write down what we want to prove so that we have a goal to aim towards. So WTP want to prove. Originally, we wanted to prove if n plus m is odd, then n is not equal to m. We are going to prove by contradiction. Sorry, not contradiction, contrapositive. I can't spell. Can't even read. So we're told prove by contrapositive. So we want to show that if n equals to m, so we want to show the contrapositive statement, which is if n equals to m, then n plus m is even. That noise. All right. So to prove so this blurb up here is to essentially write down our goal. Our goal originally is to show if n plus m is odd, then not equal. We're going to prove this statement is true by using the contrapositive. So if we can show that if n equals m, then n plus m is even, but because proving contrapositive is the same as proving the original one, then we've done the work. So we start our proofs by indicating that it is a proof. So what is the proof? Well, if n equals m, so we're supposing, suppose that n is equal to m. So because that's our if statement. So if something is true, so we suppose that it is true, right? We want to somehow get to that n plus m is an even number. Okay, so suppose n is equal to m, then what is n plus m? Well, n plus m is n plus n because n is equal to m. We said we suppose that was true. Or n plus n is 2n, right? If you're doubling something, it's always even, right? Because 2 is a factor of that number. So which equals 2n, which is even because 2 is a factor, right? Because you're doubling a number. So therefore, we've shown that if n equals m, then n plus m is even. So we've shown the contrapositive to be true. So therefore, the original statement is true. So if n plus m is odd, then n does not equal to m. So there's several things to write in terms of proofs. We usually start with proofs by writing down our goal. We want to prove our original statement, which was if blah happens, then blah happens. Right now, we're going to use the technique of contrapositive to show our proofs. Next lesson, we'll look at another technique as well. So contrapositive says, if we can prove if we can show that not Q implies not P, then that is the same as showing P implies Q. So we need to say, well, what technique we're using. We're proving by contrapositive or contraposition, which says that if not Q, which is n equals to m, then not P happens. Then we start our proof by saying, this is my proof. So proof, suppose that they are equal, because that's the if statement. If something happens, so if n equals m, so suppose it does happen, then we need to show that n plus m is even. Well, n plus m means n plus n, because n and m are the same thing. 2n, right? N plus n gives us 2n. Doubling a number is always even because 2 is a factor. So you finish off with, therefore, we have shown that if n equals m, then n plus m is even, which means that because of contrapositive statements, we have shown the original statement, if P, then Q holds true. and you finish off by writing down what you have proved. So contrapositive, remember we start off with our original P implies Q. Contrapositive says not Q implies not P. So if not Q, then not P. If we can show the contrapositive is true, then automatically the original statement is true. On the other hand, the converse, remember Q implies P, tells us nothing. If you prove that Q implies P is true, that tells us nothing about the original statement of P implies Q. So don't use converse, use contrapositive instead, which is not Q